Hi guys. Here's the video for the number 9 third quarter benchmark review. And this is on School City. So this assignment is on School City. And so it might help to log in and get the assignment up and then go through it with me while I go through the problems. So basically it focuses on two things for third quarter in 8th grade. And there's some stuff that we didn't really have time to do, it just didn't happen, but we still have another quarter left. So the first thing we focused on was graphing with slope-intercept form, and this is mostly to solve a system of equations. So the idea was that if you could graph two equations together, put them together in a graph, then you could see where they cross and figure out what the solution is. So for example, if I could graph two, and let's say they looked like this and this, then the solution for them is the place where they cross. So that point that's there. So we're not actually going to practice problems that have this in it, but this is the reason that we're practicing graphing, is because we want to be able to graph two at the same time and figure out what the solution is for them. So you probably will see problems like this on your benchmark test. The other main focus for this quarter is scatter plots, which scatter plots are a lot like what they sound like. It's a scattering of points. And these are always in some kind of real world context. Like you could be talking about, let's say, study time versus test score. So let's say you're going through and you're comparing how much a kid studies to how high their test score is. So as the study time increases, so as the study time gets bigger, it looks like the test scores are also getting bigger, which makes sense in real life. But that's the reason scatter plots are useful, is that you can kind of get an idea of like what happens with a data set and then make conclusions from it. So there's lots of problems like that, which we'll talk about. This works a lot like slope. So it definitely, goes with this because you use lines here to make predictions. So here we were using lines to figure out the solution on this side here, where we're graphing to solve a system of equations. So this side here, we're graphing lines in order to solve a system. Here we're using graphed lines to make predictions on a data set. So they're definitely related topics. Okay, problem number 1. A line and a right triangle are shown in the graph below. What is the equation of the line? So remember that a line is in slope-intercept form, y equals mx plus b. M is the slope and b is the y-intercept. So really all I have to do to figure out what the equation is to fill in m and b. So I'm going to look at this and say, okay, well, here's my y-axis, and it looks like it crosses here in the middle. So that means my y-intercept is 0. And then my slope is that triangle, right? It's represented by this triangle. So to get from this point up to this point, I would have to go, looks like over 7 and then up 4. So this is my rise. This is my run. And so if this is rise over run, then the up and down part here comes first, and then the side to side part is on the bottom as the denominator. So this would be 4 over 7. So this is 4 over 7 here for m, and then plus 0. So y equals 4 7ths x plus 0, which I obviously don't have to write that plus 0, right? Leave that off. And so my equation here is A. All right, problem 2, very similar. If you're trying to write the equation of this, you're doing the exact same thing. So m and b. And if I look at my y-axis, it says this little triangle piece here is going down 2.5. So that must mean this point here is 2.5. So my y-intercept is 2.5. And then my slope is how much it's changing by, which you'll notice on this problem, it's being represented as a decimal. But you can just kind of still set it up like a fraction and then view it as a decimal. So let's set this part up the way we did last time. So here this time the 2.5 is my rise, but since it's really going down, right? It's going down negative, it's negative 2.5. So my rise is negative 2.5 over the run, which is 5. And so if I view this as a math problem, negative 2.5 divided by 5. Remember that you can go into School City and sometimes they have a calculator that's available to you in the 8th grade. I believe you get a regular calculator. So if I put in negative 2.5 divided by 5, that's negative 0.5. So really what I'm saying is that this is negative 0.5. So y equals mx plus b means that this is negative 0.5 for m, and then 2.5 positive, right, for b, and I just need to put in that x and the y. So y equals negative 0.5x plus 2.5. So don't get thrown off. Oh, sorry, this is negative 2.5. That's gray. See, at least though, if you're paying attention to answers with multiple choice, you can definitely sometimes figure out where you weren't paying close enough attention. So this is negative because obviously it's down here in the negative area. So this would be minus. So really my answer is A again. All right, problem 3. So now we're starting to talk about scatter plots a little bit. You'll notice this one has number of pages here. So you're comparing what happens as the number of pages increases, what happens to the weight of the book. But you'd expect if there's more pages that the weight's going to go up, right? And you can see that here because this has a positive correlation or trend or association or relationship. They use all kinds of words here to describe this here when they say what is the correlation, but really it works just like what you already know about slope. So this is a line, if you kind of blur your eyes, like pretend, I don't know if you wear glasses, but if you pretend like your glasses are off and you're just looking at all these points, it looks like they're moving up, which is positive, and that means that both things are increasing at the same time. It's an increase relationship. Number of pages increases as weight increases, and weight increases as number of pages increases. They both have a positive correlation. They increase together. Okay, slope of this line, I always tell students you're gonna mix it up. You're gonna probably know it's not this or this, but then you're gonna forget if it's undefined or 0. Remember, think of this as a ramp. Either this ramp is a flat, useless ramp. So it could be like a ramp, but it doesn't really help anybody in a wheelchair, or it can be an impossible ramp, meaning it's really just a wall. You can't go up it because it's straight up and down. So this is the flat useless ramp, which is a slope of 0. And this is the wall, which is a slope that is undefined. So this would be 0 because it's flat. All right, this one shows a ramp. So notice that this uses the idea of a ramp too, pretty common analogy for slope, but it's again, just rise over run. So M is rise over run, which means in this picture, it's 3 over 9, which obviously you should reduce. All right, here's one where it says, which of these statements is true? So the graph shows his wages increased and that the number of customers served increased. So this is saying increased. This is saying the graph shows no relationship. The graph shows that as his wages decreased, the number served increased, or as wages increased, they decreased. So you're kind of just trying to pay attention to like which direction the line would go. If something was increasing, that's when you're talking about having a positive slope where both things are going up at the same time. So it's going to be moving upward. No relationship means it's going to be scattered like everywhere. Like they just don't really look like they make a line. They're just kind of all over the place. As wages decrease, you don't really talk about this bottom number here decreasing. So this right there is not a very good statement mathematically. So I would say C doesn't really work. Here you'll notice wages increase again, and it talks about servers decreasing. This is where you'd get a negative slope, where you'd end up going forward and down at the same time. So here you're going forward and up in the positive area, and here you're going forward and down. So this graph shows no relationship, in my opinion, right? If they're kind of just scattered everywhere, doesn't make a line. Which statement describes an outlier? So I always tell students that outliers are like loners. They are points that hang out alone. So it's the value in the middle. Nope. It's the value that's an abnormal distance from the other values data. That sounds good. Largest, smallest? Nope, those aren't true. So yes, it is the one that has an abnormal distance from the other. So it's a loner point. All right, Megan measured a candle as it burned. Which graph shows the height of the candle in relation to the amount of time it is burned? So you're always looking at X as moving forward. So if time is moving forward, what's happening to the candle height? So in real life, if you think about it, over time, the candle, which started out tall, is going to get shorter and shorter and shorter, right? So the idea is that as time moves forward, the candle is going to get shorter. So you're looking for something that's going to match this, right? This height of the candle here just keeps getting smaller and smaller and smaller, kind of like the picture I just showed. So this has a negative trend or relationship or slope or whatever it is that you're using to describe that relationship. Whereas like this is nonlinear, doesn't make sense. The candle's not going to suddenly get bigger over here, right? Unless you add more wax to it. Certainly the candle doesn't get taller and taller, and it's not going to be all over the place that way. There's definitely a relationship between candle height and time. All right, Josh had to read a section of his book for 4 days. He recorded the number of pages. It shows you that list there of how many pages he read on which day, or pages he read on based on how many minutes he also read. So I'm going to pull my calculator back up, and I'm going to look at it like, if I'm looking for the rate that he's reading, I'm really looking at pages per day. Oh, oh, you know what? So, okay, let's reread this more carefully. So it's giving me multiple pieces of information, right? It's giving me amount of days that have passed. It's giving me a certain amount of pages that this person has read. And it's also giving me a certain amount of minutes that it took him to read those pages. And so if I look at this, it says on which day was his rate of reading the highest? So we're comparing the number of pages to the amount of time it took. So this is not true. It's not days. It's the amount of pages per minute, per time, right? So since we're recording in pages and in minutes, it's pages per minute. So the first day, I can just go through and just fill these in. So the first day it was 27 over 4. The second day it was 33 over 40. The next day it was 15 over 7. And then the day after that, 42 over 58. So let me pull my calculator back out. 20. Oh, you know what? That's not a 4, that's a 34. That's 34 here, which makes more sense because I was like 4 minutes. Whoa, the kid was speed reading that day. All right, so 27 divided by 34 is 0.79. 33 divided by 40 is 0.825. 0.83, I guess we rounded. Although we can already tell between the first two which day he was reading faster, right? 15. Oh, again, that's 17 minutes here. So I guess when I was writing over it, I was getting a little bit too grand with my gestures. Here, let's erase that. So 15 divided by 17 is 0.88. So already I can tell that the day he was reading, why isn't this writing? Oh, it's erasing. 0.88. And then finally, 47 divided by 58, 0.81. So these are pretty easy to tell that the day he was reading the most pages per minute was the third day. The day he was reading, he read 15 pages in 17 minutes. So this is just a rate problem, which relates to slope. If I was making some kind of graph or something, this would definitely create some kind of data relationship I could look at. All right, I don't need my calculator for now, at least. Lauren ran a race. She was able to keep a steady pace of 10 feet per second. So her slope is 10 over 1, 10 feet every 1 second. So which line on the graph represents how many feet she runs over time? So I will say right away, I can say no to A, because that's negative and she's not decreasing as time goes by. She's getting further, right? Her distance is getting further as her time is getting further. And C also I can delete because that says she has a slope of 0, which means she's not changing. Her distance is staying at 10 the whole time. So she's basically just standing still. And so then I have these two, and I just need to figure out which one of these is 10 over 1. So which one goes up by 10 and over 1, which looks like it's going to be B, right? Because every block is 10 up and then over 1. So 10 over 1 is going to be B. I had to cut this one up weird because it wouldn't fit on one page. A teacher took a survey of an 8th grade class. After finishing the survey, he found that there was a strong positive linear correlation. So basically you're looking for something that's going up because it's positive and straight line because it's linear. So it's not curved. So if I look at this, this is straight line, but it's not going up. This one is not a straight line. This one is not a straight line. And this one is a straight line that is going up. Which one is the best fit for the scatter plot? So if I'm looking at the scatter plot with just blurred vision, it looks like the points start in this area, right? And then move up around here. You can definitely tell by the location of them that it seems to be that that line there in the middle, kind of in the middle of all those points here, is the best fit. Because A and D are too far away and B is tilted the wrong direction. Sasha observed a hawk and recorded its height from the ground. She observed the hawk flying high in the sky, and then it swooped down to pick up a mouse, and then it flew back up to its original height. Which graph shows the hawk's height? So these graphs are kind of cool in that they kind of look like what the hawk would do if the hawk was flying. Not always true, though. It's kind of a bad habit to get into that. You should think about it, but sometimes it looks the way it would actually look in real life. So the hawk is starting out high up, right? So if I'm looking at height here, I'm looking for a graph where the hawk starts out high up, and then over time, the height gets lower, and then the hawk flies up again. So this is the answer, A. This one shows the hawk on the ground and flying up, but then going back to the ground. This one shows the hawk flying from the ground, just up somewhere. And this one shows the hawk up in the air, flying down to the ground. So definitely A. Maria wants to buy a car that costs $2,000. She starts with $600 in her savings account and adds to the account every week. The graph below shows. Assuming she continues to save at the same average rate, how many more weeks will it take for her to save $2,000? So this is really just a rate problem. Slope, right? So slope here is that she's starting out at 600. So her y-intercept is 600. And then she adds to the account every week. And it shows for the first 4 weeks. So from here, 600, it looks like after 1 week now, she's at 750. So 0, 600, 1, 750. And then she goes for the next week, she's up to, looks like 950. And then the next week she goes to 1100. So this isn't completely linear, but you can tell in general kind of how things are moving. So here she goes from that 1100 up to 1300. So it kind of looks like there's a line, right, that's moving this direction. So if I'm trying to figure out for 2000, which is here, when she hits that, it looks to me well, based on that line, that's 8, which isn't even one of my options. So let's look at this and see. So she goes up on the first week by 150, and then by 200, and then by 150 again, and then by 200. So maybe we'll just kind of continue that pattern. So up 150, and then 200. That seems like 8. Assuming she continues to save at the same rate, how many more weeks will it take? A weird problem. I'm not sure I agree with that answer. I'm going to look more closely at this. I would say, I mean, based on the idea that I got 8, doesn't seem like 5, right? Because look, how could she jump all the way up here to 2000 after 5? Oh, is it maybe how many more weeks? There we go. How many more weeks? So that makes sense. So that's going to be all these blue ones I drew. So up 1, over, and then over. So it looks like more weeks make sense. So these are the first 4 weeks here in red. And then here are the second 4 weeks in blue. So if we're talking about how many more weeks, then I disagree with 5. I would say it's 4 weeks away. All right, that makes a lot more sense. All right, this one is a pretty easy question. It's just asking which of the data is most tightly clustered, meaning which ones are closest together. And so that would be A. This one's asking about outliers. So here it shows you the original graph. And then each one of these has a piece of that graph circled, asking which part is the outliers. So you're looking for the part that's away from the rest. So this is inside this line, I would say, right? This looks like they kind of go together. This looks like it's clustered together in these lines, but this is definitely away from the line. So B is the right answer. Which statement describes a negative association between two variables? So negative would mean that X, the first number, so I'm talking about a situation where this is increasing, but this is decreasing. So you're looking at something where it's going down that way. So as the value of one increases, the other one increases. That's not right. That's positive. As one increases, the other becomes more clustered. No. As one increases, the other decreases. And then as one increases, the other stays the same. So this is not right. This is true. Which one shows the line of best fit? So here is the original graph, and it's asking which line fits it the best. I think you can kind of just use intuition on this. You're looking for the line that seems to be in the middle of most of the points, which this one is too far up, and this one is tilted wrong, right? It's not going through the most of the points. This one is okay. And this, I would say A and B are both okay examples. Keep in mind that this line of best fit is an estimate. And if you're in a class full of people trying to study something and they're all creating their own line of best fit, you're probably going to see different kinds of setups. But these two, I would say, are probably both sort of okay. This one goes through a bunch of points, which is kind of nice. And this one kind of goes through the middle of those points. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9 above, and 1, 2, 3, 4, 5, 6, 7, 10 below. So you can kind of also look at it like how many are above and below. This one's kind of a toss-up for me, honestly. I guess I would go with B. But I'm kind of curious what the answer on this one is. I think A and B are both kind of legitimate. A kind of looks like it fits in the middle, but then B goes through more points. So I would choose B, I guess. All right, the graph below shows the distance that Marissa's bus travels over time on the highway. So Jeremy travels by car along the same highway. His speed is measured by this equation. So this is Marissa here. And then this equation here is Jeremy. So his speed is represented by 65t is D, where D is distance and T is time. So as time increases, Really, so if this is kind of, if you're thinking about this in like slope intercept form, this number here is the number that's in front of x, because in this problem, t is taking the place of x, right? Because t is on the bottom here where x would normally be. So this number in front of x is 65. So his slope is 65. He's going 65 miles per hour is basically what that means. Whereas Marissa, you'd have to look at her picture here. So she's going from 0, and it looks like the next good point. It's hard to tell. I'd say that's a pretty good point here. So it looks like she went 110 in 2 hours, which is 55, which also should mean that there should be a point at around 55 here, which there is right there. So this is 55 miles per hour. So if we're asking how much faster he's going then, Marissa, he's going 65 and she's going 55, which is 10 miles per hour more. Which equation represents the line shown? So this is back to the beginning couple problems we did. So again, this one crosses the y-axis at 0. So my y-intercept is 0, which is all of these are, right? They all have a plus 0 at the end. But then from here, it looks like it goes down to this point or backwards to that point. But you're either way, you're going down 3 and then over 5. So I'm going to have a slope of -3 over 5. That should be y equals -3 over 5. A car's odometer shows the total number of miles the car has been driven. Denise records the odometer reading on her car at the end of each week for 5 days. She then represents the odometer reading with this graph. Which equation could be used to represent it? So keep in mind on this that m in this case is y and d is x. So you're really just trying to set up a situation where you understand what the m and the b part are for that y equals mx plus b that we keep talking about. So if I'm looking at y-intercept, that's going to be here at 10,275. So I'm looking for an equation that does not, that has this number by itself, because this is the number at the end that's by itself. So if I look here, it has a d next to it, and here it has a d next to it, so I can eliminate c and d. And then I'm looking for my rate, which now I have to be a little bit more careful. So I'm down here at 10,275, and it looks like sometimes it's hard to tell where the points are. It must be extra hard on your guys' side if you have a small screen in front of you. I mean, I guess it goes all the way up to here. So 10,550 10,550 minus 10,275. It's 275. So to get from here to here, I have to go up 275. And then to get all the way from 0 to this point, it's going over 5. So my slope is 275 over 5, which equals 55. So the rate here is 55. And then it starts at 10,275. All right. Getting close to the end. Scatter plot shows a relationship. Which statements is true? Choose all that are correct. So the line of best fit will pass through the origin. If I think of that line of best fit here, yeah, I agree with that. It does look like it'll go through the origin here. The slope of the line of best fit is negative. No, that's not true. There is no association between the variables. No, I'd say that's pretty linear, right? The relationship between the variables is linear. I agree. The relationship between the variables is positive. I agree, it's going up. And it's nonlinear. I disagree. So I would say A, D, and E for that. All right. For this one, it's asking which is the line of best fit. Hopefully you can tell right away that M is not going the right direction. N is not going the right direction. P is not going the right direction. So really, line O is the best choice there. This one is basically simple slope, right? And y-intercept again. So y-intercept here is 0. And then my slope is going up 5/8. I'm looking for y equals 5/8 x plus 0. All right, last problem. And then I'm going to pause this video and check on that one answer I wasn't sure about. 4 lines are shown in the graph below. Which line has a slope that either increases or decreases at the largest rate? Which means most tilted. So think about if these were all ramps and you're going to put a ball at the end of them, like the highest end, which one would fall the fastest? Which this seems like here it would fall the fastest, but I will say this is undefined. And in math, that means it's not calculated as a number. So it's definitely not D, but it could be A, B, or C. So which one of these would have the most, like the fastest ball that would slide down that ramp? And I think kids can kind of intuitively tell that just from playing, but A would definitely be tilted the most. Which you could go through and calculate these too, but you can also just kind of use your eyeballs. Okay, I'm gonna pause this for a sec. Okay, so the answer for this one is A. So I will change my official answer and say that it's A for number 18. And I will say this was my first instinct just based on the way it looks. It kind of looks to me like it's tilted the best and in the middle of most of the points. But the other part of this is that it goes through here a bunch of these different points and seems to have, you know, an equal-ish amount of points on each side. So again, I think it's an estimate. And if we were in class, I would be impressed as a teacher with either one of those answers. Whereas I would say C and D are definitely. Okay, good luck. Let me know. This recording ended up being a little longer than I expected, but let me know if you have any questions or if there's anything I can help. And good luck on your testing tomorrow.